Let us now solve question 11. We'll solve both the A and the B part. In the diagram, ABCD is a cyclic quadrilateral. Line segment BC and AD are produced to E. Angle ABC is 2T, angle CEF is 5T, and angle DCE equal 51 degrees. We have to find the value of T and angle ADC. So since this is a cyclic quadrilateral, we can recall that the opposite sides, the opposite angles will add up to 180. So angle ADC plus 2T, this and this, the opposite angles, will add up to 180 degrees. So angle ADC will be equal to 180 minus 2T. So 180 minus 2T. So if that is the case, we can find this angle here too. When we add this and this, we should get 180. So this is supposed to be 2T. So this is 2T, this is 51. When we add 2T and 51, we should get the exterior angle here. Or we can also transfer the 5T into this triangle. Then we use the fact that sum of the interior angles of a triangle will add up to 180. In either case, we get the same result. So let's add this and this. 51 degrees plus 2T should be equal to the exterior angle, which is 5T. So 51 degrees will be equal to 5T minus 2T, and we have 51 degrees is equal to 3T. Divide through by 3, we get T to be equal to 17. So the value of T is 17. If T is 17, angle ADC is equal to 180 minus 2T. So angle ADC, so this is I. Angle ADC is equal to 180 minus 2 times T. T is 17. Then you're going to have 180 minus 34, which is equal to 146 degrees. Let's look at the B part of the question. The graph of the relation y equal x squared plus ax plus b, where a and b are constant. Cast the x-axis at 3 and the y-axis at 6. Find the values of a and b. Use the values of a and b to solve x squared plus ax plus b equals 0. So if the graph cuts the x-axis, the x-axis or the x-intercept in this case will be 3, 0. So we can see that x equal 3, y equal 0. So we have y equal x squared plus ax plus b. So when y equals 0, we have 0 here, equal x squared, 3 squared, plus a times x, 3, plus b. So this will give us 0 equal 9 plus 3a plus b. So negative 9 will be equal to 3a plus b. Or b is equal to negative 9a, negative 9, b is equal to negative 9 minus 3a. We can call this equation 1. Then again, we're told that the graph cuts the y-axis at 6. So that point will be 6 comma 0, the y value will be 6. So 6 0 or 0 comma 6. So we can fix 0 for x and y, 6 for y. So we have 6 is equal to 0 squared plus a times 0 plus b. So we're going to get 6 is equal to 0 plus b, which is b. So the value of b is 6. So if b is 6, then we can fix in b equals 6 into this equation. So that will give us 6 is equal to negative 9 minus 3a. So we have 6 plus 9 is equal to 6 plus 9 is equal to negative 3a. So we are going to obtain 15 is equal to negative 3a. When we divide both sides by negative 3, we get a to be equal to negative 5. So we find the value of a to be negative 5 and b to be 6. So this equation becomes the II, x squared plus ax, a is negative 5, then b is 6 plus 6 equals 0. So we have x squared minus 5x plus 6 equals 0. So we look for factors of 6 that when we add we get negative 5. These are negative 2 and negative 3. So if we expand this, we have x squared. We split the middle term to obtain x squared minus 2x minus 3x plus 6 equals 0. So we have x into bracket x minus 2 minus 3 into bracket x minus 2 equals 0. When we collect x minus 2 as a factor, we obtain x minus 2, x minus 3 equals 0. Then either x minus 2 equals 0 or x minus 3 equals 0. So we have x to be equal to 2 or x to be equal to 3. So these are the values of x that makes the equation x squared plus ax plus b equals 0 true.